All right, hello and welcome back to the third and final session of Lightning Talks at SciPy 2019. Woo! Yay! Look at you dedicated folks out here. So we have a brief announcement before we get started today. So if Melissa and Matthias want to come up and yeah.
So we have two small announcements. So after the lightning talks are the buffs. So if you expect on the schedule, they all have the wrong room. So if you come for SciPy, it's here. If you come for training and skill building in open source, it's going to be in room 204. And if you're going to help to organize SciPy 2020, and you should volunteer, it's going to be in room 203. We have also another things about buffs that have already happened.
So just to make sure that you all know, if you need to reach us, if you feel like you should talk about something at the BOFs, at the talks, at the conference in general, remember you can reach out either in person or via Slack or Twitter. If you follow me, I'm at MelissaWM. On Slack, I'm on the diversity channel, the general conference channel. You can find me there too. So make sure if you need to share anything, to make comments or whatever, just reach out to us, okay? Thank you.
Especially if you want your comments to be shared anonymously with committees or something like that. We're here, take your word, we can rephrase if you're afraid that the way you write will be recognized. I know, like, as a French person, it's really easy to figure out when I'm talking or when I'm writing with my terrible French accent. So we're here for you, so feel free to reach us either in person or with any way, but feel good for you. Thank you.
Thank you both.
To the pen master now.
Yeah. And first up, we have Gwen.
So welcome, Gwen.
Welcome, Gwen.
Thanks, everyone. All right, so I'll be talking to you about programming quantum circuits with Docker. Just a really quick plug for a current company I'm working for. I am a data scientist at Perfect Day. We create dairy protein without the cow, and we're hiring. So if you're any of these roles, if you have any experience in any of these roles, come talk to me after, and I'll tell you a little bit more about the company. And if you want to learn more about what we do and how, just go to our website, perfectdayfoods.com. So now I'll give you the scoop on what this talk is about. So in a previous life, I was a quantum engineer, and I did a lot of talks and demos on quantum programming. Like, how do you create your first hello world on a quantum computer? And very quickly, I found out that the first sort of bottleneck there was to get everybody's environment set up. So getting the Anaconda environment or just getting Python installed, people would come with their laptops, just didn't work out. And very quickly I found out, like, having virtual environments is really nice, but then I wanted to give this other talk where I sort of made the Rosetta Stone for quantum programming languages. So I took these 5 programming languages, Q#, Quill, Project Q, Qiskit, and Cirq. So for those of you not familiar, Q# is made by Microsoft, Quill by Rigetti, Project Q by ATH Zurich, Qiskit by IBM. So for people who saw, I'm wearing this swag. So this is one of the sponsors, and Cirq is by Google. And so the tools that I ended up using for this were Binder, Python, Matplotlib, and Qtip. But what I found out quickly is that Q# actually requires you to install .NET on your computer. So that didn't work with Binder, so I was like, oh no, what am I going to do? And then there were also some problems with installing Qiskit. There was this weird issue where they said it's safe to ignore, and it should not be fatal. So it worked, but there were some weird things, and people got confused, so we just decided to virtualize all the things. This is very meta. This is a screenshot from a lightning talk about Docker in Texas in 2013. Okay, but yeah, you want to so they put your virtualization layer on the virtualization layer. So basically, Docker is a very lightweight virtualization platform. Virtualize all the things. So let me just quickly go to the repo. So So you can find the repo here. It's on my GitHub. I made a shorthand for it, quantum.gwen.pw, if you want to find it. So what's in here? If you pull this repo, you'll find this Docker file. So Docker file is basically like a recipe for a virtual environment, for a virtual machine. So it has this sort of format here. You can install different things in different steps. These are all cached. We're running out of time. And if you run it, oops. You can just do Docker build, and it starts building the container, and it also works with Binder, and that's really cool because you can just start coding right away.
Yay!
All right. Thanks for showing us how to read the Docker.
That's good. I could make a pun, but I'll try to contain myself. Up next is Tanya. Are you here now? Tanya Lar? There you are. Okay. So you're on deck. And what does it mean to be on deck? On deck means that when Madikin is crab walking the current speaker off of the stage, that means you're making your way onto the stage. So that's why you have a seat down here for the first timers and future SciPy attendees. So what's the first thing you're going to do at SciPy when you come back next year, first timers? You're going to try to sign up for Lightning Talk, isn't that right? Huge head nods. Just everyone said yes. They also said, Paul, you sound great today. Thank you. Thank you. Really appreciate that. All right.
Okay, hi. Hi, I'm Matthew Fikert. I'm going to talk to you very quickly about PyHF, which is a pure Python theme library from the high energy physics community that uses tensors and autograd. So I am a particle physicist researcher at the Large Hadron Collider, which if you don't know, is a super awesome 27-kilometer circumference discovery machine. And we use it, my colleagues and I, to ask questions about the foundations of the universe, such as what are some of the properties of the Higgs boson, which gives mass to fundamental particles, and what is dark matter. And we use particle detectors like Atlas, shown here, with humans on the left arm shown to scale to try and ask these questions. But when we found the Higgs boson in 2012, we implemented our statistical models in a computational graph, but it was pretty complex and pretty difficult to actually do and not a lot of fun. So as an analyst and a researcher and a developer, I want to try and decrease the time to inference and discovery so I can focus much more on the physics in hand. And so I joined with my collaborators, Lucas Heinrich, Jordan Stark, and Kyle Cranmer, to build PyHF, which is the first pure Python implementation of this particular statistical model that we used for the Higgs. And so PyHF uses tensor backends with auto-differentiation to build efficient computational graphs, shown here, that actually give us much more performant fits. And so the traditional C++ implementation is up top, and then the PyHF is on the bottom. To the left is better. And then that allows us to spend much more time actually asking the universe what it is. And so this work is being supported by the Institute for Research and Innovation in Software for High Energy Physics, IRIS-HEP, I'm a part of that. And the particle physics community is trying to get much more serious about software, especially as we gear up for the next round of the LHC. And I would love to talk to you much more about particle physics and Python, so I'm here for the rest of the conference and for sprints tomorrow. And if you want to talk to me online, my Twitter is there. Thank you very much, and thanks for an awesome first SciPy.
Yeah, I also look for dark matter, using Python. I thought you might have found it, so I said, at last.
I thought I'd enjoy being up here, but I'm just getting tenser.
I just like this choice in fashion.
So up next, Nick Del Grosso, are you here? So you're on deck. Make your way over.
Take it away.
All right, I'm going to be talking about ensemble topic modeling. So first of all, what is topic modeling? I don't have a lot of time to explain all of this. So it's modeling a corpus of documents in terms of underlying topics. And I'm putting topics in quotes there because really topic modeling is just matrix factorization. So let's go through matrix factorization very quickly. I'm taking a big matrix of data and I'm expressing it as approximately a product of two nice small matrices. So on the left we have the data. The red set is our representation of their data. It's a low-dimensional representation. And then that's multiplied by a set of archetypes. So you can think of a single row of your data as a representation multiplied by this matrix of archetypes. So it's essentially a linear combination of these archetypes. Now, if your features happen to be words, you magically declare the archetypes to be topics and you're done, you're doing topic modeling. So LDA and PLSA are two methods for doing this, and they're based on sort of a probabilistic matrix factorization approach where the reconstructed matrix is sort of your probabilities of seeing the data. LDA is the really popular approach to this. PLSA was published a couple of years before LDA and was sort of a precursor, pre-step to doing it. But it looked really interesting to me, mostly because it was incredibly simple. It was exceedingly simple to write the code to do it, so I wrote code to do PLSA, wrote it all with numbers so it goes incredibly fast, and then I looked at doing ensembles. So let's just start with PLSA. What's the performance like? So here's LDA from scikit-learn and non-negative matrix factorization as well. They take 2 or 3 minutes. The PLSA implementation that I wrote ran in only 40 seconds. So obviously I'm probably doing something horrible and just turning out terrible answers, but it turns out that actually in terms of scoring this, in terms of how well it was doing better than the others. So this seemed like a big win. But the next problem is that this sort of topic modeling approach is a little unstable. What I mean by that is if you run it once, you get one set of topics, you run it again with a slightly different random seed, and lo and behold, you get an entirely different set of topics. And that doesn't convince people who are looking at these topics that you're actually producing the real set of topics underlying the data. You're just randomly generating noise. So how do you fix that? Well, what it comes down to is these are hard optimization problems and the topics vary from one round to another based on that, but we could try and ensemble this together and find the stable topics. So I want to shout out to this pull request that went into GenSim that wants to do an ensemble version of LDA. I ended up taking a slightly different route than they did, but this was really the inspiration for what I did, so I want to make sure they get credit for what they did. So the guts of the idea is that you can take all these topics and you can dimension reduce them if you like and do it in the right way, and then cluster it and pull out clusters of topics after you have a whole lot of runs. Running out of time, so each topic represents a stable topic, and you can do even better with a whole bunch of runs. They all run in parallel. It's great.
Changing topics and random noise. Your code should run for Congress. Well, we're not allowed to do politics? Sorry, I'm new to the pun table.
Simon Cross, you're up next.
Lately with the microphone on the table.
Oh, yes. Hello, everyone. I hope you're enjoying SciPy, and I'm here to help with the SciPy Blues, presenting SciPy 2019. This is going to take place in Bilbao in Spain. There is an international airport. It's only 4 hours away from Madrid, so you can always take some nice holidays, and the food is amazing. On that note, there are networking events in the Cideria, which is a cider house, and it's accompanied with pinches that are very, very nice foodies to do some networking. Well, 2 other big EuroPython have already taken place in 2015 and 2016 in Bilbao. And we've announced our first keynote, that is Sarah is on for the Event Horizon Telescope, and we're in generating the first image of the black hole. The program is announced. Please ignore my face in that slide, but if you need enticing, you can go and see the program and the full list of talks and workshops. We also have some participating projects, so people from NOMBA, scikit-learn, MapLab, your favorite packages are going to be there. And then this year there is a full track dedicated to maintainers supporting maintainers. And if you or your employer are looking for an event to throw your money at, please use SciPy. The call for sponsor is still open. You can find more information on the website that is SciPy.org and our Twitter account that is SciPy. And see you in Bilbao in September.
More like Bill Wow, am I right? All right, up next, who do we have, Paul?
Min, are you here? Talking about NoaViz? Min.
Who's the next then, on the other sheet?
Then it's Jen.
Jen Darrow, I probably horribly mispronounced that. Europe.
That was continentally bad. Incontinentally bad.
Hi, I'm Nick. This is my first SciPy. Thank you very much for a great experience. I just finished my PhD, and I want to share a little bit of my experiences and what I've been thinking about. So this is going to be a little bit of a kind of random cluster of ideas that hopefully has something interesting there. I studied neuroscience and psychology, and when I came to Germany to do my master's, I wanted to build machines that interacted with human brains, and we worked with stroke patients that recorded from the brain in order to help them recover from stroke. The idea was that as they got feedback information from the machine, they learned how to control their paralyzed arms and recover faster. More information meant faster learning. I mean, everyone knows this from machine learning. But it turned out that the better treatment was teaching them how to pick up toothbrushes or stand or cut their food or things like that. It turned out the intentionality of the past experiences had much bigger effect than the intentional design of the engineers. Later on, and this got me to appreciate this idea called Conway's Law, that the way that information flows between systems affects and during the design process affects the design itself. For my PhD, I used Python to build a virtual reality system for rats, and we were able to show that even that by removing constraints, rats were able to naturally learn how virtual reality environments work. It turns out they understand video games just as well as we do, and that was not known before because all systems were built by virtualizing their movement. By forcing them to turn these little balls, people weren't able to see that they actually understood how to walk around. This has been known a lot in design, especially in visual design, that even though technically you have all of the information available, we're more primed to understand some things other than others, and that causes us to interact with things differently. So whether that's color maps, or whether that's, and that's where we set our zero axis. And declarative libraries like ggplot2 or my favorite Seaborn have changed the way people approach the design, their data analysis process, and allow them to get more insight and actually explore more of their data than they would otherwise. One thing I'd love to see, if you're an author of data visualization library, is cat size. There are error bar plots, there are error bars in almost all the data visualization libraries, but these actually discourage people from expressing error in a way that's intentional. Look up cat size, and I hope we see a lot more of these in the next year. Lately, I've been training scientists to learn programming, and seeing how scientists approach the problem of programming. Approach the problem of programming well, anyway. Oh my God, they're coming after me. I'm so scared.
Thank you very much.
Rats in virtual reality, that's amazing.
Ooh. Do you know what a rat's favorite game is?
What's that?
Hide and squeak. Yeah, that's what this conference needed. More rat noises on this.
That joke was pretty cheesy.
And on deck is?
At the tail end of this list here.
So Chris is at the airport, so that's going to be difficult.
That's going to be hard.
All right, take it.
Leah Wasser?
Cool. Hi, I'm Simon. I've got 180 seconds to change your view of the scientific method, so let's go. A common view of the scientific method is that it consists of formulating a hypothesis and then conducting experiments to falsify or confirm this hypothesis. I think this view has a few problems. Firstly, it suggests a very black and white picture where hypotheses are either right or wrong, and it paints a picture of science as a large body of disconnected statements. It prevents a very narrow view where experiments are of primary importance, and I don't think it matches what actually happens. These problems are far from academic. Science encounters a significant amount of skepticism, and societal views are often polarized. I don't think the common view of the scientific method is really helping here. When people are bombarded with many short, disconnected statements and not given any tools to connect or reason about these themselves, it's not surprising that many of them become confused. I think a more useful view of the scientific method is as building and characterizing models. Let's take vaccines as an example. I'm very sure that the measles vaccine doesn't cause autism, and if someone came to me with that evidence that it did, I'd be fairly skeptical. But this isn't because I've done a lot of experiments of my own or read papers by experimenters I trust. It's because I have a simple model in my head of what the measles vaccine is, an attenuated form of the measles virus. Thus, it seems rather unlikely that the vaccine would do something the virus didn't. On the other hand, the Qatar incident in the 1950s, where Qatar laboratories distributed vaccines accidentally containing the live polio virus, seems very plausible given the model. If we're going to win over science skeptics, we're going to have to explain our models. This is a harder kind of educating than stating facts and hoping to be believed and hoping that we were right in the first place, but no one said that this was going to be easy. Science is about model characterization. We build mental models and we characterize them. We expand their consequences. We understand when they're valid and when they're not and how accurate they are. And we simplify and improve them. Models come in many shapes and sizes. They might be as simple as a drawing or as complex as a standard model of quantum mechanics. Experiments still have a unique value. Their measurements are independent of our models. But how we decide which experiments to do and how we interpret the results is very model dependent. As an added bonus, this model-based view looks kind of Bayesian and solves the all ravens are black paradox. But more importantly, a common set of models allows us to have a conversation, even if we disagree about the details. They allow us to come to shared conclusions and have constructive disagreements, to have a shared mindset. Models that are well characterized can be depended upon in their domain of validity, and they allow us to have the what-if conversations that are the basis of policy. For many important issues, we can't perform experiments. We only have one planet and one life to live. Thank you.
Thank you.
That was too deep for puns.
Too deep for puns? I mean, I was under the impression data science was blue this whole time, but apparently it's black and white.
So we're gonna try again. Min, Kant, Zhao, and maybe, I don't know, this is very, no? You're not here? Noah Viz? Anyone else want to talk about Noah Viz? All right. So then on no.
Sorry, that was a real flood of comments then. Get it, Noah, Viz? No.
If not, I don't have to show some.
Well, there's. All right, then on deck we have Jules Fowler.
Maybe?
Yes.
Nah. I can just wing it.
So I can tell a funny story while that happens.
But can you?
I can try.
Okay.
No, I won't have to. You're spared.
That was the funniest thing you've ever said, Paul.
Thank you. I'll take a bow.
Yeah.
That was a happy story.
Oh, there we are. We're good.
Okay, we're good. All right, I'm Jen Darrow, and I'm a graduate student, and I'm taking my first natural language processing class. Yay! And last month I built a racist sentiment classifier. And I'm not telling you this because I'm proud of it, but I'm telling you this because it's a cautionary tale. So what I wanted to say is I followed, did it go away? I followed, okay, I'm not gonna do that anymore. I followed the instructions on a great blog post, how to build a racist AI without really trying. And I wanted to see it work for myself because I'm just learning about the idea of word embeddings. And how many people here use word embeddings already? Some folks? Okay. So I was amazed at the idea of having points in high-dimensional space where words were next to each other if they were related. You can see man and woman, and you can see king and queen, and they're related, and it's fantastic, right? But then I became aware of the fact that some genders are farther from educated, and some religions are farther from healthy, and some, ethnographies are farther from employable, and things like that. And so I found out about this by reading this blog and seeing it myself, and being able to type in sentences of my own and see, certain ones were very positively scored and might come up with it in a recommendation engine for who should be my graduate advisor, or, how is it going to pick things that it recommends to me in terms of new movie directors and things like that. And so I thought, I wanted to make sure that I let you guys know about this, because friends don't let friends build atop biased word embeddings. And so I wanted to let you know that there's alternatives out there. There's a great project that was put out a few years ago that goes with the blog post, and I'll, let's see if I can show you the blog post here. And it's called ConceptNet Number Batch. Pun company, come up with something. So they're fantastic, and they have gone through a bunch of the word embedding vectors and de-biased them, like moved them more neutral, so that we have more accurate predictions as well as being unbiased and more fair. So I wanted you to be aware of this. Tell your friends. Friends don't let friends build atop biased word embeddings. Just, be aware of this. Thank you.
Sorry, that sounded like Benedict Cumberbatch there. I never knew he was a racist AI.
Up next, is John Meese here?
HDMI?
Yes.
Hey, Paul. Hey, that last talk, we heard a little bit about black and white data science. I noticed you're wearing a lot of shades of gray.
Where is your buzzer USB? I need to plug it in later.
No, I said no. I was just going to say two. You're mixing it.
Okay, spared from my story again.
Yeah, so I guess I need you here, Paul, maybe? Take this.
All right, I'll take it.
So this is...
and we've never met before, yes?
No. Who are you? So this is Lightning Talk on Jupyter and hardware, and I'm Wolf, and
I'm Paul.
Hi. And
am I going to need a hand for this?
I hope so.
Okay, I'll put this
So we got this awesome devices. Paul, can you show it? And me and my colleague, Martin, we were wondering, okay, what to do with this thing. And it's obvious, turned it into a game controller, so use the potentiometer as an input. And there's this new fancy library called SciPy Canvas. You should check it out. So here we got SciPy Canvas Pong. And I'm not going to show you everything because I got more to show. So now you got the flickering and everything. I'm controlling this one. You're the other one. You turn the... Oh, my God.
Oh,
it's a game controller. Yay! Woo!
Oh,
okay, you lost. Oh.
Not fair, not fair.
I thought you'd be better at this. So anyways, you start out with this, and obviously the next step, the next step is to build a spaceship. So, okay. Can we plug this in?
Let's do it.
Yes. Well, good.
Am I going to need a hand for this?
So yeah, that was the first multiplayer game in the notebook, I hope. And now that's another first. So there's other cool hardware, and I'm going to show you a library that was released yesterday by Jason Grout, which is called SciPy MIDI Control. And let's see if it works. Yay! So here we have a MIDI controller, and we got some knobs, and we can turn them, and you see the value change in the notebook, and I can press some buttons. So we got our control set up for our spaceship, basically. We can also set values from the notebook. It's a complete widget, and you can get a UX like this, and you can turn knobs, and you can press buttons, and they activate in the notebook. And then you can also do a random dance. I don't know if you can see it. It's lighting up yellow and stuff.
Ground control to me.
Yay! I didn't know you could also sing.
I can't. That's
but for a spaceship, obviously, we need a bit more than that, right? So there's also already the gamepad flight simulator from Sylvain. He showed it a couple of years back, and that's already an iPad widget, so we're getting there. And then no one is going to go to space alone, so you need your cute companion. This one. So there's a library called Jupyter Ross that I was working on, which you can use to visualize your robots and control them and make them dance. And that's it. Woo!
Boy, live demos are hard where you have 3 things to show.
On the other hand, it's good to see a good experiment-y.
Sorry, on deck, Tim McLennan. Tim, you.
Spared again. Oh, maybe not. Oh, I hate it when it works.
Okay, hello everyone. I'm Jules Fowler. I use they, them, theirs pronouns, and I'm a software engineer at the Space Telescope Science Institute. I'm here today to tell you about what I like to call very specific robots in outer space, but is actually more about interesting exoplanet problems you can solve with Python. So what are exoplanets? If you see the annoying little title at the bottom of my slide, they're planets, but with less fun names. Instead of Mars and Jupiter, we call them things like WASP-13b and TRAPPIST-17e or something like that. And the real reason we do that is because they're planets that are circling around other stars. So who here has heard of the Goldilocks planets from a couple of years ago? Awesome. It was super exciting. We found a planet that wasn't too hot, wasn't too cold, it was just right. And that is one interesting part of exoplanet science. We're trying to find planets that have what we call habitable atmospheres, which means that maybe we could do some manifest destiny and move out there, or maybe there might be aliens. It's exciting. I want to believe. But that is really fun and cool in theory. And in practice, this is what it looks like, is kind of sad, weird blobs. The smaller observation is a direct image of TRAPPIST, actually. This was the observation that was the lightning. There it is, and it's what's called a direct image. And the larger image is a spectrum. And if you think that looks more like modern art than like science, that's exactly how I felt when I had to start figuring out how to do this kind of stuff. And in case you're wondering, the alien is right about there. So there are 2 really cool ways that we can approach this. If we think about how to turn that weird blobby spectrograph into data, how we find water, how we find any other features, there's this really awesome package called ExoCTK. It's both a Python package and a Flask website, so if you don't even want to code, you can go use our tools. It's all in Python, and it's a Flask application, so even the website is in Python. And it's open source, it's on GitHub, and if you've seen any of the cool talks about SciPy, we want to be the SciPy of the exoplanet community. We want to set standards, we want people to contribute their own tools, and if any of you happen to have any exoplanet tools, you should come find me after and we should talk about it. But so this is very much the how do we make data that we have turn into science. There's another interesting problem, which is how do we get better data? And that's where the fun robots come in. I'm actually really happy that the talk before me happened because he was very right. We are trying to make spaceships out of doing little motions and making things move. So this is a setup of the Macedon Optics Lab. These all are things that you can control with Python. Here's a really ugly example, and these are all of the people on those 2 teams. Thanks.
Great job.
What an excellent talk. Excellent.
Yeah.
Did you plan it, was what Matt said.
Yeah. Yeah, that was my joke too.
Ryan Grout, up next on deck. Ryan Grout.
There's no creativity anymore.
None.
Who's next on deck? Ryan.
Great. So hi, I'm John Meese. I'm the Plotly Python maintainer, and I wanted to give you a quick update on a couple of new things that are pretty exciting right now. So very quickly, Plotly.py is the Python bindings to the Plotly JavaScript library. It lets you create a pretty wide range of plot types that cover a lot of statistical use cases, geographic use cases, three-dimensional use cases. And it's just a pretty flexible overall framework. Earlier this week, we released the first release candidate of version 4 of poly.py, and I wanted to just run through my top 3 highlights that I personally am most excited about. First is this Poly Express integration. In March, we released a tech preview of this project we call Poly Express. It's a high-level API for building statistical style complex plots from tidy data. You can think about it as analogous to Seaborn. The way Seaborn helps you build complicated matplotlib plots, this helps you build pretty complicated and sophisticated poly.py plots. So that's now integrated directly into the library. There's a new renderers framework that we've been able to use to generalize the old way we had to display plots with the kind of offline iplot function, if you're familiar with that API. Now we can support a much wider range of contexts for rendering plots, like the classic notebook, Jupyter Lab, VS Code, Interact, even Colab and Kaggle notebooks online, Azure notebooks. For contexts that don't support interactive plots right now, like QConsole and Spider, we have a static image renderer that lets you display static versions of plots inline as well. And finally, before version 4, there was this kind of complicated, to explain, situation where the same package, the poly package, could be used to both create plots offline and also to upload them to this Chart Studio cloud service. It's been offline for a long time. You've been able to do it, but it's been confusing to explain. We've totally pulled that online stuff out of the Plotly package. So in version 4, when you install Plotly, the Plotly package for Pivorconda, you will have no access to any online stuff. There's a whole separate package called Chart Studio that has all that in it now. So hopefully that's clear to understand. If you want to learn more, you can check out my Twitter account. I pinned the community forum post on the release candidate, and we'll have a full announcement coming out in the coming weeks. Thank you very much.
Well, that was impressive. Now you can quickly render your plots onto your laptop so that they're offline.
I really see where the inspiration was born from. Yeah, that was the appropriate response. Who else is, who's next on deck here? Amal? Amal? Yes, yes. Oh, great, come on up.
That looks good. Cool. Hi, I'm Tim. I'm a first-time attendee, and I'm going to tell you recently about a journey I went on. As you might be able to recognize from the picture and from my accent, or maybe you've talked to me, I'm actually based in Christchurch, New Zealand. I may be a first-time attendee, but I'm a pretty long-term user of the scientific Python ecosystem. In fact, it started when I and the company I work for started developing applications around 15 years ago in Python 2.0. But I'm not going to talk to you about that. I'm a research engineer, so one advantage of that is I actually get to explore some interesting ideas rather than deal with things like the legacy issues of dealing with Python 2 in your applications. And in this case, I'm going to tell you about the big blob of green you can see on that picture below, on that map below Christchurch. It's known as Lake Ellesmere. It's the 6th largest lake in New Zealand. And, well, it's green compared to the other lake in the top corner because it's pretty polluted. In 2010, it was the second most polluted lake in New Zealand. And we recently started working with some domain experts around maybe looking at whether we could use satellite data to look at this sort of stuff. So, well, this sort of problem, what do? You get some data and then you put it into a Jupyter notebook, create some pictures. And so this picture is of one of the two major indicators of poor lake water quality. It's called TSS, which stands for Total Suspended Sediment, and it's an estimate based from satellite imagery. The other one is chlorophyll A, which we might come to in a little bit. Then someone gave me a handy hint, maybe actually this isn't quite the best way to do it. These images can be pretty big, takes a while to download from the server and then throw it into the notebook. So I moved on, and someone suggested using Google Earth Engine, put together, had to code some JavaScript. Not so good, but apparently there is some Python support for this. And then the next step of my journey, I actually jumped on a plane to come over here. That took a while. It was about 16 hours in the air, and pretty much a day later, and then we arrived in Houston, ready for the conference. Oh, quickly, all right. So I jumped into tutorials. They were pretty awesome. I did a couple, one on telemetry and one on panel, and then I went to put together something there, and look at this. You can go and do some cool stuff. So thank you to the tutorial instructors. And I'll finish with the comment, I'm really looking forward to giving back something tomorrow at the sprints.
So the problem with those, the problem with those big images, they don't sell well.
I was going to say that was a really long flight for a really short talk.
It's also great how far and wide our community is. Even in the South, they use Python too.
It's the deep South.
Got some serious data science going on.
I'm just feeling blue.
Not sure. Usually it just goes on. Okay. Is this unexpected?
Hurry up. We've got a story coming.
Nothing's happening.
Oh, so the story. So funny story.
It's like I have a display for it as well.
I lost the Sprint sign-up sheet. So, and when I figured that out, so there was the last sheet. So we're up to speaker 37 now, but the last person, the last 10 people, so 30 through 40, were on that sheet. I lost it. And I tell this to Eric Jones, that was here for the opening reception, then flew to Japan, and then just came back just to see the closing lightning talks because he likes me so much. No, he just came back. He happened to be traveling for business. First thing Eric Jones, Event Thought, tells me is, that's great. I was like, that's great. What do you mean? Why is that great? He's like, it's great because I didn't do it, and it's something that I would have done. So then I'm looking around and people are trying to say hi to me and try to get me to do other things. I'm like, sorry, I'm looking for this thing. I can't find it. And because it's the last sheet, we're going to have speakers. I don't know what to do. And we're good over there. We're good over there. To be continued. To be continued.
All right. Okay, I'll begin now. My name is Ryan, and I just want to show you just a quick little thing I was working on as a personal project. So in Python 3.7, there's a new language feature added called data classes. And at first this excited me because it allowed you to do stuff like this. And if you haven't used adders before, basically what it does is it generates an init method for you that takes in all your class variables, and then assigns them for you. So for instance, here, because A is not assigned a value, it'll throw a fit until you pass it a value, and then it's happy. One thing bothered me though is the implementation of data classes requires that you annotate types. So for instance, that will give you an error because A is not defined, it's a syntax error. Well, not name error, sorry. And this is not a data class because there are no type annotations. So data classes are the only place in Python where you are required to do optional typing. And that irritated me just a little bit, but I wanted to do something with that if I was going to have to do it. So I decided to use it with SciPy widgets. SciPy widgets has an interact feature which will inspect the function signature for types and generate a set of widgets for you. So here A is an integer, B is a float, and you get appropriate sliders. So I decided to write something that I could give a data class, and it would give me sliders and float sliders and a text box and a list. They don't do anything, so let's wire it up to do something useful. Disclaimer, this is a super hacky, like, proof of concept thing, but I'm rewriting it so it's a little more robust, and that will be what I release as a package later. So this allows you to sync the state of a data class to a set of widgets and back again. So for instance, I move this and see automatically updates with the sum of the squares up to 34. And then I have a history of all the states of A, and then I can control the slider with B. So it allows you to create interfaces with the typing information from data classes. And I'm done. I'm done.
I was with you when you said syncing the state, Ryan, because I believe that all data are important, and I'm a bit of a data Marxist. I believe in a data classless society.
Insert HTML.
Next on deck, we have
a good joke.
Elizabeth Ramirez. Are you here, Elizabeth?
It does say Thursday, please.
Oh, it does say Thursday, please. Oh, when did that get added? Elizabeth, we're sorry. Wait, must have been when I lost my sheet. Well done, Matthias.
Who's next, Glenn?
That's it.
That's it?
Val? Yeah, so.
We don't have any more sheets. All right, take it on.
Cool. Hi, everyone. I'm Amal Bhatnagar. I'm here on part of the Division of Data Sciences for UC Berkeley. So if there are any Berkeley or Cal alum out there, go Bears. Nice. So I'm a rising junior studying data science and economics at Berkeley, and I'm here to talk about how we can advance the undergraduate education for data science across the world. So as of right now, a lot of employers want people who can work with data. They don't necessarily have to be data scientists or analysts, but just people who are comfortable with data and who can manipulate and visualize. Glassdoor has ranked data scientists as the hottest job for the past 3 years. There are a whole bunch of different articles out there on why people should now learn data science. And so far, a lot of the resources have been restricted towards master's and PhD programs. And a lot of undergraduate institutions now want to get into the field, but they can't necessarily do so because of a lack of resources, and there's not a standard because it really hasn't been done before. So it's very uncoordinated. In 2015, UC Berkeley launched a data science course at the undergraduate level for undergrads. And since then, we've been able to start a data science major, which was launched this past year, and we're starting a minor this upcoming semester. And so over the past 4 years, we've learned 4 main things. One, for an undergraduate to have a strong data science program, they need to have an intro to data science course. They need to have scalable infrastructure. They need to be able to have courses that apply that data science to different domains, as well as they need to be able to teach students how to ethically use data after graduation. And so the Intro to Data Science class at Berkeley is called Data 8, and it focuses on 3 things. 1 is inferential thinking, 2 is computational thinking, 3 is using real-world evidence. And the idea behind this is being able to teach students who have no Python experience whatsoever to be able to work with all this. The second is the infrastructure. So we have 3 main things. 1 is a campus-wide Jupyter Hub. The second is a learning management system. We use Canvas. This is meant to connect the students with the professors. And the third is having an autograder, so that as there are more students, it's easier to scale, and instructors don't have to spend that much time on grading. So Berkeley has 3 different courses. Well, the first is the intro one. The second is an upper div. They use NBGrader. And then we have an edX MOOC class, which uses Gopher which was recently launched. And so once we have this data science, we need to be able to apply it to other places, which is why we have 2 different things. 1 is modules and second is connectors. Modules are existing courses which embed data science within it, and connectors are brand new courses that are based on data science. And so the last part is using ethics and being able to teach students that they really need to be able to ethically act on data. And ever since in the past year, we've been able to influence these different institutions to start data science courses or programs. Thank you.
Thank you. Oh, you know what the difference between a data scientist undergrad and a fish is?
What's that?
You can auto-grader, but you can't auto-tune a fish.
Auto-tune, that's good.
That one needs some workshopping.
So remember how I said SciPy was first to be in the field of deep eating, the burritos talk that we had on the first day?
Yeah.
Remember? Well, Berkeley had data 8.
Oh, nice. Well, so we'd like to invite anyone who'd like to give an impromptu lightning talk.
This is a bit of a trust fall we're doing here. Yeah. And so to finish up my story, I'll finish it after Val's talk.
Anyone else who just come right on up. So.
Hello everyone, my name's Val. I work for Anaconda on the Number project, and I'm going to be talking to you today about number integration testing. So the problem we have sometimes with our release candidates, we make our release candidates, and ideally they're sort of designed to sort of check if we're going to break any dependent libraries. So we release them. There's like a mailing list. We put them out there, and then we expect all of our dependent library authors to go and check them. But sort of people have lives, and so that never happens. And then we release the original version. The release, that's good, and then people come back to us and tell us, well, you broke my library, please release a hotfix. So that's obviously not an ideal situation, so we decided, we want something more automated. So the solution here is something I call number integration testing. And what we do is we test the latest release of our dependent libraries with the latest number master sort of nightly. So for example, if you have a library called Spam Ham Eggs version 42, we test that with the number master. And hopefully that will avert the need for hotfixes. So this is what it looks like. It runs on Circle CI, it runs nightly, and it's an entirely non-bash solution. So this is entirely written in Python. It reports to Slack, and it works really well. We've managed to smoke out a couple of issues already. So for example, for the current release, we would have accidentally broken PyGBM and awkward, but we didn't because we managed to check that ahead of time. We also managed to find a whole load of use of undocumented non-public number features where the API had changed under the hood. And we also found some breakage that was caused in dependent libraries by new releases of other libraries that they depend on. So that was a nice little side effect. So the next steps, we want to generalize the code base, turn it into a reusable library. We want to set that up for Dask, and I'm going to sprint on it tomorrow. So please come to the number sprint if you're interested in this or if you want to talk about it. So it's currently blocked by a very complicated problem in computer science that I'm sure you're all aware of, which is lack of a good name. And sort of if there's any time left now, I've used, I think, 2.5 minutes. I'd like the panel to suggest a bunch of names for me.
All this talk of smoke and hot fixes, it just makes me think you should call it barbecue.
That's a great idea.
I don't have a name, but it did remind me of my college calculus class with its integration testing.
It's kind of derivative. That was kind of derivative.
All right, so to wrap up the story of how I lost the sprint sheet. It may have been stolen, I don't know, but I found it. Things are okay. And you would think that, I'm a responsible person. Okay, thank you. Matthias knows me too well. I found it, and I wanted to report back to the people that I had worried that, that I had lost it. So when I tell that to Eric, he goes, well, that's too bad. And then I tell that to Jill and Jody from Menthought, and I tell that to Matthias, and he also says, that's too bad, man. And so the lesson I learned is I need to screw up more, because apparently good things will happen when I screw up. And when I fix things, it's... I'll stop talking now.
He still doesn't know the end. Okay, so lightning talk before the lightning talk. For some repository, GitHub has enabled new things on teams where you can assign a team only triage possibility on GitHub. So if you want during the sprint, bigger font. If you go on GitHub, you should have said that for the planet discovery things. So if you go on GitHub for some repository now on settings and collaborator on teams, you can now give only triage permission to some people. So if you want to get help to triage issue during the sprints, I would recommend you to look for that. So that was not my lightning talk. I must say that I want to really say thank you to Matplotlib because they keep backporting things. And actually, they're using one of the backport bots that we're using in Jupyter. And if you want to see how many backports projects are doing using our bots, you can go to this page. I will share the URL before. And you see that, well, many projects are actually doing the effort to backport bug fixes and documentation fixes and typos for Matplotlib to previous branches. And you see that it's quite active. And you can basically look at what's happened if you see also what Matplotlib is doing. They just dwarf everybody. So in the last year, Matplotlib backported close to 1,000 pull requests. So we just want to say thank you to the Matplotlib folks. Just to show you how it works in case you want it for your project, here is Matplotlib PRs where they enable the bot. They have a milestone. If you look at the milestone, on the milestone it says on merge, backport to 31x and merge to 311 doc. I don't know why they have to think for docs. And so once they merge the PR, the bot will automatically emit a backport for the PR. And now you just have to merge it, and you have your backport on your stable branch or long-term support branch. And that's it. It was to give time for others to write their lightning talk. Thank you.
On behalf of the Matplotlib folks, thank you for writing MySeqsDev. MeSeqsDev. MeSeqs. That was the end of the story.
You should screw up more.
I should screw up more. MeSeqs.
Okay, I have a suggestion for a name for the last package. Numerology. Yeah, very trustworthy.
All right, hey folks. So I wanted to talk a little bit about a package that I help maintain for data management. I work in a lab that does a lot of computational material science, and frequently we're faced with a lot of big parameter sweeps that we want to make, where we want to understand how things like pressure and temperature or different kinds of particle interactions affect the resulting crystal structures that we can assemble. And so the SciPy data management framework is a toolkit to help with problems like these, where you're dealing with file-based workflows, especially on HPC systems. So I wanted to give a brief example of how we can use this. Our website is SciPy.io, and you can find our documentation at docs.sciPy.io. So this year I took a class on advanced data mining, and we were analyzing a data set of airline tickets, over 1 billion rows collected between 1993 and 2018. And we needed a way to automate all of this data processing so that we could do a variety of different network analysis methods and extract communities from this structure. So we had all this in CSV files, and we were able to write Python functions which we could automate as SciPy flow operations on a cluster. And so SciPy flow generated the submission scripts for us, so we didn't have to think about anything besides how much memory we wanted to request and how many CPU cores we wanted. We were able to use this effectively with a PySpark cluster as well. And basically what we found was that if you consider only one-hop tickets, so you take an airline from one place to another. If you consider the communities in that way, your network actually just thinks that the whole United States, except for Alaska, is one cluster. Alaska is its own cluster. But if you consider that most people actually take return flights, you find that there's a lot richer community structure here. So we were able to extract that through this data analysis project. And it ended up being a lot less code than I expected it would be due to the automation that SciPy was able to provide for us. You also get some kind of cool stuff where you analyze like which airports are hot in the summer and winter by page rank. You can see that Florida, pretty active in the winter. People like to go there. So this repo is available on GitHub. My username is bdice, B-D-I-C-E. It's in my pinned repos. And if you're interested in learning more, you can check out the poster, which is also in the GitHub repo. There's a paper there. And this is the website for Signac. So thank you very much.
I wanted to request more memory once, but I forgot.
Cool.
All right, next up we have Travis with Lightning Talk. And then again, if anyone else wants to come up and give lightning talks, I think we've got a couple more, so please get on deck.
A rush of people. Is this working? Not yet. You have one of these already.
So Travis, is this your first SciPy?
This year, yes. No. It's my first SciPy this year. Okay.
I'm glad you've been continuously integrating with the
Mirror
community.
displays, there we go.
Travis.
Is it good? Give it a second. Okay. Hey, everybody. SciPy. It's amazing how we've grown. This is awesome. We've grown so much I can't get a talk in. I have lots to say still. Those who get a chance to talk to me in the hall will know I've got lots to say these days still. But I can't get my screen to work. Nothing?
Val says it's the year of the Apple desktop.
That was good.
That was good. Okay. Well, okay, there we go. I have just a bunch of slides here I'm going to go through really quick. I am really active still, doing a lot of things. I left Anaconda, which I started 7 years ago. I left it full-time a year ago. I really am trying to search out how to fund open source. I feel really, NumPy and SciPy are fantastic projects, but I feel a little guilty. I feel like there's still no funding for them. And I knew that was a problem when I started, because I'd read economic literature and I understood the problem of shared spaces, and we need to have funding for it. We're doing some things still. We have something called Quantsite Labs. Our goal is to hire a group of core developers for the NumPy SciPy stack. Ralph Gomers is helping do this. He's jumping back in with the core NumPy developers and the SciPy developers. This is our goal, to work with the community. Lots of things we're trying to do for funding. I've actually started a venture firm. If you want to talk to me about how venture financing can actually help fund open source, got lots of ideas about that. This is one way we plan to continue to fund open source for a long period of time. Open source directions, Anthony, Carol Willing, David Charbonneau, is a great, come on and talk about your projects, talk about things you're doing in the community. This is a really fantastic time to talk and get to know people. We're still doing lots of cool projects. This is just a couple of them. I have really big goals. If you want to come talk to me about them, I'll talk your ear off about what I'm trying to do. But XND it's in alpha mode, but it's libraries. If you're out there trying to do development with array objects, you're trying to figure out a type system, XND's got a lot of stuff in there, and it's all C libraries, so it's not easy to use for an end user, but if you're a developer, it might have something there you might be able to use. So check it out. XND UArray, we all heard about this problem of merging, of different array implementations. UArray is an effort in that direction. Organizations we're starting. When we started Continuum, NumFocus, Anaconda were spin-outs of Continuum. I like that model. We keep doing that. Quantsite is the Continuum continuation. And so Quantsite also does spin-outs. We've got FaroSS. Anthony's leading at FaroSS.com. It's still early stages. Open Teams being relaunched July 15th. Check it out. There's a lot of cool things happening there over the coming months and years. This is something that bothers me a lot. We have a divided community again. I stood here 13 years ago at SciPy to talk about NumPy and how it would help unify the community. 12 years later, we're in a much worse situation. I do not know how to solve that as quickly, but I think there are things we can do, and the problem is that we are doing this. And the same thing that caused me to sacrifice tenure to write NumPy is happening with the silos. So we gotta fix this. So, got 2 seconds. So, there's things happening I haven't heard talked about here, but it's happening. So come check it out. XND is a project that's happening. Our NumPy is happening. UArray is happening. Come talk to me about these projects. They're happening. You can be involved. Thanks.
I think it's great. I think it's probably a problem that we can solve with deep learning, right? I mean, it solves everything.
I mean, QuantSight's name is a pun, but that's not the only reason I work there, so. All right, next up is Maddie, and yeah.
Who uses SciPy? No, not that one.
No. That one's
So I want to
PyPI.
talk to you about PyPy, P-Y-P-Y. It's a fast implementation of Python, and because it's fast, I'm not going to say much about it. You should try it out. Maybe the slide will come up, maybe not. PyPy, go to our website, pypy.org. It's a Python with a JIT.
Wrong screen.
Oh, well. It's all right.
Linux stuff.
And try it out.
There are no PyPy jokes? None?
I'm not that fast.
Can't come up with any, like, just in time, maybe?
No.
Not that fast.
Not that fast.
That's very late. Just want to say thank you to all the volunteers that helped to do this conference, Paul and Anthony in particular. Big round of applause.
Hi, I'm Abigail Searfoss, and it's my first time at SciPy. I can't believe I'm doing this, to be honest, but I am going to show you guys an app that probably none of you will use, but I've developed to analyze songs of birds. And the reason why I'm showing you, since you probably won't use it, is because it uses Kivy, and I feel like I've seen a lot about the visualization and widgets here, and I'm excited to try out new ones, but I felt like Kivy should be represented as well. So I was just going to show you how it kind of runs and what you can do in it. This is my first Python project, so anybody can learn how to use Kivy. You can create all these different toggle buttons and input factors, and then you can even go in and choose folders. Unfortunately, mine are kind of deep here. Let's see. Let's do these. And so you can make pop-ups and use buttons, and then I've used matplotlib to plot sonograms of bird songs, and you can use sliders to adjust the visualization and your different levels of signal or how the lines are getting implemented. And these are all added in as well. And you can even play songs through it in WAV files. And you can also do touch events by adding additional lines. And this is all done easily, like I said, by somebody who's never really done this before. And you can just keep doing this and have warnings, and that's all.
Someone should mention how cheerful that app is on Twitter.
I think some of those folders could have been nested.
Okay, so I'll be really quick. Basically, this is a project that I worked on this week during some of the breaks because it's something I've actually wanted for a long time. It's a time machine. So basically, the question is, what if you want to install packages with pip as if you were, say, 1 year ago or 2 years ago? And so now you can do this with PyPI time machine. So essentially, the way it works is you run a command, PyPI time machine, and then you give it the data you want to go to. So let's see, so 1st of July 2018 goes there, and then gives you the URL here, and then you can basically, I'll just make this a bit bigger. You can pip install and then index URL. You give it this index and you say you want to install, for example, AstroPy, and it will go and fetch basically AstroPy and all the packages. All the dependencies and everything will be as if you were at that date, and so that can be really useful if you're doing development and you want to have a kind of consistent ecosystem at some fixed time in the past. So it's called PyPI time machine, and yeah, I'd love if you give me any feedback. Thanks.
I think that we need some way to find out who the authors of those packages are, so we don't have to say Doctor Who.
The building a time machine, that was like the DeLorean of talks.
Hi, everybody. Awesome, I appreciate it. Okay, so I've heard a lot of conversations about diversity, and how diversity and inclusion is going to, can be improved at SciPy, in our workplaces, and that's really encouraging. It's also something I think about a lot, partially because, on my route to development and on my route to speaking, a lot of people had advice and, bits that weren't so helpful. And I won't bother you with any of those stories, but I want to make it extremely clear that, I've been working on a talk literally about the talks that we don't see, like the folks we don't hear from, the stories that we choose to tell and the stories that we don't. And it's been striking me how difficult it is to even write or speak about this topic, so I decided to get up here and say something really impromptu in front of several dozen people, just to kind of pull the scab off. Nobody laughed at that. Thank you. But, we think that speakers have to be experts, and if we don't think that, someone implies that to us, like, there's a certain amount of surprise that we see pretty frequently. People give advice. There's no amount of power stances that's ever going to help someone, get to a feeling of competence, whether we're willing to stand in front of a room and talk about something, whether they just learned it or whether they've been working with a tool for 5 years. So I hope that we can make a shift from the way we talk about supporting speakers, supporting folks who don't look like a whole lot of other folks in tech, and to kind of moving away from kind of a quick fix mindset, that this will be prescriptive, we'll do this and things will be okay, to shifting to this is going to be a long haul. Because even making the shift from, saying I'm someone who doesn't speak to saying I'm someone who will stand up and speak about a sensitive topic in front of a room with absolutely no preparation, that's a, it's a market shift, but it's also has a lot of, support that's been needed along the way, and people nagging me and myself nagging myself, and it has not been one choice or another. So hopefully when we're having these conversations in the future, it'll be a little easier for us to remember that it's really a big picture and a long haul that we're looking at. Thanks.
Thank you very much.
Thank you very much, Veronica. I want to say something that sort of dovetails for what Veronica just said that I was going to say anyway, not knowing she was going to talk about it, which is that we've come to the end of the talks portion of SciPy. And for those of you that are not staying for the sprints, we wish you would. We're going to miss you tomorrow and on Sunday. But even for those that are staying, remember that when we all part here, that there's frequently sort of this feeling of from the highs that we have experienced over the last couple of days, you will probably, many of us, I know I will, feel very down on Monday when I'm not with my SciPy family. So remember to take care of yourselves and be mindful of that it's a natural part, it will happen just because of all the good things that have happened here. And so I just want to remind everyone that that's something to prepare for and to take some extra time to take care. So I know that's not funny, but just sort of I just want to make sure that everyone takes care of themselves.
It's important.
Yeah.
Thank you, Paul. And let's give a big round of applause to all of our Lightning Talk speakers at SciPy. And thank you so much to everyone who came up and participated, and Paul, and the pun panel and the new speakers especially. It was really lovely to see all of you here. I think the BOFs are next, and I guess one last personal announcement is that this will be my last time hosting the lightning talk. So next year, it'll move to someone else. Some very confident people. So thank you all for a great run.
Thank you. Thank you, Anthony.